Hello, welcome back. So last class we have discussed about definitions of important terms. Like just we have I have introduced only two terms. That is, first one is period and second one is the frequency. Now let me discuss about what exactly happen, what exactly the waveform will be of the particular AC sources, right? So here waveform, it is defined as the graph between graph magnitude of a alternating quantity against time. So here we have taken the magnitude along y-axis and time along x-axis here. So this is the first wave, that is, if we can represent AC oscillations as a sine wave or cosine wave or any other wave. So here we are represent those are called as sinusoidal waves, right? So here this is a sine wave where it is started at 0 and its amplitude is 0 here, and after time certain time its amplitude is getting increasing here, then it is decreasing, then once again increasing. So it oscillates along with time. So this is one type of a waveform of the AC, and the another one is square wave where its amplitude is will be represented with a maximum value or minimum value. So maximum value we call here as a 1 and the minimum value as 0. Here also once again it is a maximum value 1 and once again it is 0. So it will be oscillating 1. So once again we call this one as also an AC oscillation, right? Then now we can represent another one waveform in a triangular waveform also. So there once again it is also oscillating term and it is alternating also. So here it is a positive one, here it is negative. Every waveform will have this nature. At 0 it is a 0 value, and it reaches to the particular time it reaches the maximum value, then it comes to the 0, once again it goes to the maximum, then it comes to the 0. So its magnitude will always change with respect to time, and its polarity also change, means that is nothing but an alternating one, that is called as AC. So now we can represent in a complex wave also. So this is the form of a complex wave, where it is a particular it changes the its amplitude changes with the time, but it is not in a perfect sine wave or triangular wave or square wave. It is somewhat a complex wave. So here also it is also a alternating one, because it has a positive cycle and once again negative cycle. Its amplitude increases decreases with time, so it will repeat. So that's why it is called as a AC oscillation. Now another one term that is called as a phase. So let me introduce a phase. What do you mean by exactly phase? So you can see this diagram below, right? So first I will define this, what is exactly the phase means. Phase is nothing but it's a state of vibration or variation. It's a state of variation, state of variation, because a particular wave will vary with respect to time, as we know that, right? It is a fraction of a time period that has elapsed after. It is a fraction of the time period elapsed after the voltage or current has passes through the reference value. So you can see this diagram here. See this. Here it is a sinusoidal wave. After a certain time, this wave is getting it's moving. Its amplitude is changing every time. Here it is this value, and here it is this much value. It's a maximum value here. Here once again it is a somewhat less value, and here it is 0. So it is oscillating, but here we are representing this particular origin as a reference value. After the particular elapse of the time, how much of that wave is moving forward or lagging backward, that defines about the phase here. So you can see this diagram. So this is called as a phasor diagram we represent. The phasor diagram means, see, at particular at 0 its value will be 0 here, as we represent oscillations in the form of theta. So as it is, if you take the particular value at this point, this vector will be making a certain angle theta, that is nothing but a omega t, because it has a frequency also and it is moving with the time. So that's why any oscillations can be represented in the form of a circular phasor diagrams. This is called as a phasor diagram. Phasor diagram. Okay, phasor diagram. Depending on the wave which is getting forward or backward, we define its phase. So As we represent any waveform as a any quantity, that is whether it may be a current or voltage, we represent V is equal to V maximum value into sine of omega t. As here we have defined that one as a E is equal to, that is the total voltage, that is equal to Em maximum amplitude into sine of omega t, because this wave represent about a sinusoidal one, right? So any wave in the form of a current or voltage can be represented in the form of sine. So even we can represent the current as I equal to I naught sine of omega t. So here, so this particular omega t represent about the its phase in which it is there. It tells about the state of that particular quantity, right? Similarly here, depending on the quantity which is getting leading or lagging, so we represent a phase difference. You can see this in this diagram. The phase difference, it is defined as a angular displacement between two zero values or two maximum values of the two alternating quantities having the same frequency. In this first diagram, first case, you can see that there is no phase difference at all. At time is equal to time 0, so its amplitude is exactly 0. So means that with respect to the reference point, it is 0. With respect to the reference point, as time is varying, its value is getting changed, right? So similarly, with respect to the same this phase 0 value, if you take the second case, see here, at exactly 0 with respect to reference, as it in this case this amplitude is 0 here, in this case its amplitude is not 0, it's non-zero, means its value is, its amplitude is 0 at the certain value of the phase where it is in a backward direction. If you go at this particular value, it is getting 0 at a particular time. Before the reference point only it is 0, at the reference point it has a maximum value. So that angular displacement, a difference between the angular displacement, that is called as a phase. Here this plus phi is called as a phase difference. It's a positive phase, right? So if you see the third case here, as the time t is equal to 0, with respect to the first diagram, its value, as here we have a 0 value, here we have its negative value here. Okay, we have negative value. So that's why we call this one as a, at a particular 0 value it has a negative value, means its value, its amplitude becomes 0 after a certain time. After certain times, means this is its phase is negative phase, because it is getting lag. It is getting lag, means it is coming later, and here it is in a forward. That's why it is a forward, or it is a leading one. It's a leading one, because at time t is equal to 0 it has a maximum value. At time t is equal to 0, as it has a positive value, it has a negative value, means it is getting late. This diagram or this wave is getting late. So that is called as a phase difference. With respect to the particular reference value, the alternating quantity which is getting forward or backward, depending on that, we tell it is called as a phase difference, or it is called as a phase, right? Or it is also defined as an angular displacement between two values or two maximum values of two alternating quantities. As if you take the current and voltage, so there they get a phase difference by some amount in case of particular resistance or inductive or capacitive circuits. Okay, that we will see later on. So now, as it is a particularly about phase diagram and phasor. Okay, here let me introduce another two terms of a phase difference. That is, first one is leading phase difference, another one is lagging phase difference. As I told, it is a backward or forward. Depending on that, we represent these leading or lagging phase difference. If a quantity which attains the 0 or positive maximum value before the compared to the other quantity, so that is called as a leading phase difference, which will attain 0 or positive maximum value after the other quantity, that is called as a lagging phase one, right? So this is called as this is about totally phase difference and phasor diagrams. So this diagram which represents about the phase, so it is called as a phasor diagram. So um, and another one thing that we are going to define is instantaneous value. So instantaneous value is defined as the value of an alternating quantity at a particular instant of given time is called as a instantaneous value. As I have represented the current or voltage in like this, I of t is equal to I naught into sine of omega t, right? Where it tells about this I of t tells about the instantaneous value, instantaneous instantaneous value because it tells about the particular value of that alternating quantity at a that given instant of time at a particular time t. What is its exact value? It tells about the instantaneous value. So we can represent the instantaneous value for current, voltage and power. So we can represent the voltage also in the form of v of t is equal to v naught into sine of omega t. So it tells about the instantaneous value of that voltage. Then, so let me introduce another term of alternating current, that is amplitude or peak value or crest value, or sometimes we call that as a maximum value. Right. So it is defined as the maximum value either positive or negative, so attained by the alternating quantity in one cycle, generally denoted by capital letters. So here, let me consider this one as a sinusoidal wave. So this is what the wave is, right? So at this y-axis is represented as a voltage or current, and this x-axis is now time. So here, at time t is equal to 0, its amplitude is 0. At certain time, its amplitude will get maximum in a positive cycle or in negative cycle. Both the cycles it will get a maximum. With respect to the 0 amplitude value, so in either of the two cycles, whether it is a positive cycle or negative cycle, it will attain a maximum value. So that maximum value is called as a peak value or crest value or amplitude. We call this one as a amplitude, right? So as we represent the voltage as v of t is equal to vm or sine of omega t. Sometimes we represent this vm as v naught also, or this is v naught or vm. So that is what a maximum value. Similarly, I of t we represent as, so that is current. For current we represent I of t is equal to Im sine of omega t, where it tells about the Im tells about the maximum value, that is called as I naught we represent. So here Im is the maximum value of the current, Vm is the maximum value of voltage, and Pm is the maximum value of power. Power also can be represented in the form of sinusoidal waves, right, as it consists of voltage and current. Similarly, so here once again we are going to define another one term, that is called as a mean or average value. So here average value is defined as the average of all instantaneous values of an alternating quantities over a half cycle. Only in the sinusoidal wave, so only for half cycle, if you take the mean of the instantaneous value of that particular AC quantity over a particular half cycle is called as an average value we represent. So that is also called as a mean value. So this average value is also called as a mean value. So it is the mean value or mean quantity of the AC instantaneous AC quantity over half cycle. So as this one is the half cycle, if you take the mean value of all these AC quantities, then we will get average value, that is a mean value. So mean value or average value is defined as mean value or average value is equal to 2 divided by pi times of so into peak value. So peak value is nothing but so maximum value of the instantaneous um, uh, quantity, AC quantity, whether it may be voltage, whether it may be a current. If you represent the current, that is I average is equal to I average is equal to 2 divided by pi into I maximum or I naught. So for similarly for the voltage we represent V average as so 2 divided by pi into V maximum or V naught. So that is a peak values. So these are called as mean value of AC quantities, that is current and voltage respectively. Okay, so now once again another one term that is called as a root mean square value. So let me define that one. RMS value of an AC quantity is defined as it is the equivalent DC current, means DC means that is the direct current, which when flowing through the given circuit for a given time produces same amount of heat as produced by the alternating current. So when flowing through the same circuit for the same time is called as a RMS value. Means RMS value of an AC quantity is defined as any AC quantity, whether it is current or voltage, which produces a heat similar to the DC current, similar to the DC current at a given time is called as a RMS value. So sometimes we represent this RMS value or define represent RMS value as it is the square root of it is the square root of square root of the mean of the mean of the square of instantaneous value instantaneous value taken over complete complete cycle. So here we need to take the square root of the mean of the squares. So square root of the mean of the squares of the whole um, instantaneous value over a complete cycle. So mean value we defined only for a half cycle. Here we are going to define one full or complete cycle that we need to take, right? So this Vrms or Irms are defined as RMS values of a voltage and Irms values of a currents are defined as so root mean square of a particular quantity. So that is given by RMS values value is equal to, that is peak value of an AC quantity divided by root 2, that is called as a RMS value of a particular AC quantity. So for a particularly voltage and current we defined Vrms as Vrms is equal to V by root 2 or V maximum by root 2 because it's a peak value, and for Irms is given by Irms is equal to I maximum divided by root 2. So these are the RMS value for the current and RMS value for the voltage respectively. Okay, so it is nothing but it's a square root of a squares of mean of the squares of the instantaneous values of that particular AC quantity. Okay, so now then next term is a power factor. So I will define that power factor like this. So power factor, it is defined as the cosine of the angle between voltage and current. It is defined as the cosine of the angle of the voltage and current, or it is also defined as it is the ratio of it is the ratio of the of the true power to the apparent power, right? And it is equal to the cosine of the phase difference between AC voltage and AC current in that particular circuit as we have defined above. So this power factor is defined as a power factor is equal to cos phi, where phi is the angle between voltage and current, or this is also called as a phi is called as a phase difference between voltage and current. Phase difference difference between voltage and current, right? So this is also this is called as power factor. So as we have seen from the beginning, so these are the terms regarding AC alternating current. So that what are the things we have defined, let me see quickly. So this is the power we have defined, so period we have defined, frequency we have defined, and what are the exactly waveforms of this AC, representations. Then we saw the phase difference and what is the phase and phasor diagram also. So then we saw about instantaneous value and then amplitude, then average value, then RMS value. Then we have seen about power factor. So these are the terms regarding alternating current.